Hello, we're on 5.02 pre-calc notes today. And we're going to talk today about trig equations using Pythagorean identities. Pythagorean identities. So first thing we need to talk about is what the Pythagorean identities are. And you should have seen these, at least the top one should seem familiar to you. So sine squared x plus cosine squared x equals 1. So that is, it's like the Pythagorean theorem on the unit circle. So if you had a unit circle has a radius of 1, from here to here, you're going over, that's your cosine, then you're going up, that's your sine or your y value, because this point is cosine and then sine. So if you did cosine squared plus sine squared, it would give you 1, which is your radius. Now, if you memorize that one, which you need to, then the other ones you can actually derive on your own. So to do that, you would take sine squared x plus cosine squared x equals 1 and divide everything either by sine squared or by cosine squared. So let's start with sine squared. So I'm going to divide every single thing by sine squared. So this is how we could derive the other two Pythagorean identities. So now sine squared divided by sine squared x gives me 1. Cosine over sine is cotangent, that's your coco. So cosine squared over sine squared would be cotangent squared. And 1 over sine is cosecant, so that would be cosecant squared. So that is another Pythagorean identity. And then the other Pythagorean identity is, again, I'm going to start with the cosine squared plus sine squared equals 1. And this time, instead of dividing everything by sine squared, I'm going to divide everything by cosine squared. So sine over cosine is tangent. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine is secant. So 1 over cosine squared is secant squared. So here we just derive the other two Pythagorean identities. So then our third one is 1 plus tan squared x equals secant squared x. So these three you need to have memorized, but again, you could just memorize the first one, and if you can remember to divide everything by sine squared and then everything by cosine squared, you can derive the other two so you don't have to memorize them. All right, the steps that you guys are going to need to do here. Number 1, I'm going to want you to get all your terms on one side for these. Because anytime you have an x squared and an x, you want to get it equal to 0. Same thing here. And then use your identities to get the equation in a single trig function, in only one trig function. So that might be everything you want to be in terms of sine or everything in terms of cosine, and then you're going to solve it and factor it. All right, so let's take a look at what that means. So number 1, solve for x. 2 sine squared x plus 3 cosine x minus 3 equals 0. So first thing we did was we got everything on one side. Something else to take note of here, there's no interval given. So if there's no interval given, you're going to need to use that general form that we talked about, the plus 2n pi. We're not going to need that till the end, but just something good to note here as we're reading the problem. We need to have only one trig function. Right now, I have two. I have sine and I have cosine. So to get rid of one of them, I can use one of my Pythagorean identities. Well, all of my identities have a 1 in them and everything else is squared. So Pythagorean identities are really only going to work if you look at what's squared. So I have 2 times sine squared x. So what we can do is we can take the Pythagorean identity that has a sine squared in it. So that's sine squared x plus cosine squared x equals 1. And I'm going to solve it for sine squared. So I want to get that by itself. So to do that, I'm going to subtract cosine squared x from both sides, leaving me with 1 minus cosine squared x. All right, so now everywhere I see a sine squared, I'm going to replace it with 1 over cosine squared x. So that way I'm going to have everything all in cosine. So I'm taking out sine squared. Now this is a binomial, so it is really important that you put it into parentheses. And the rest I'm just going to rewrite. So 3 cosine x minus 3 equals 0. Okay, so now we're just a lot of simplifying and factoring, a lot of arithmetic and algebra going on here. So I'm going to actually jump to our next page. So I have a nice room here. So I'm going to distribute my 2, leaving me with 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Now I want to combine my like terms, and I also want to get my x squared, my cosine squared x to be positive. So first I'll combine my 2 and my negative 3, which would give me 1. And now I'm just going to divide everything, both sides, by negative 1, or you can think about it as adding everything on the left over to the right to get positive 2 cosine squared x minus 3 cosine x plus 1 equals 0. All right, so now we've got everything on one side. We've got everything in terms of cosine. So now we have a cosine squared and a cosine, which means we need to get it equal to 0 and factor. So you have two options. If you're more comfortable putting like an a in for cosine of x, you can do that off to the side. If you want to try to do it with cosine in there, we can do that too. So I do know that in front of the cosine squared, there's a 2. So I'm going to use p's and c's. So the p is my product of my first and last term. So that's 2 times 1 is 2. And c is my center term coefficient, which is negative 3. So I'll show you how to do it with the cosine. So I take out the middle, and instead of blank x, it's just going to be blank cosine x. Blank cosine x plus 1 equals 0. Again, if it is easier for you, you could say, let's let a equal cosine of x. Just remember here, cosine squared x is the same as cosine x quantity squared. That's what that means. So if we use the a, it would become 2a squared minus 3a plus 1 equals 0. And then you can use p's and c's on that instead. But I'll continue doing it with the cosines so you can see how to do that. So we need two numbers that multiply to 2 and add to negative 3. That's negative 2 and negative 1. Put them on my lines, group up my first 2 and my last 2. I'm going to factor out a 2 cosine x from the first set. So I'm dividing each of these by 2 cosine x, leaving me with cosine x minus 1. Can take out a GCF of negative 1 since the first number in the parentheses is negative. I take out a negative, which means I'm going to just negate everything in the parentheses. Now my parentheses are the same. I regroup, write the one that's written twice, I'm going to write once. And my leftovers are 2 cosine x minus 1. All right, so now we've factored it. Over here, if you had factored this, you would have gotten a minus 1 and 2a minus 1. And so then you'd come back and put your cosines in for your a's again. Now we're solving, so we're going to set each factor equal to 0. And we get cosine of x equals, if we add over our 1 and divide by 2, here we get cosine x equals 1. So now we're just finding our angles. So cosine of x, anytime sine or cosine are equal to 0, 1, or negative 1, it tells us it's going to be on one of our axes. So we know our 4 points. We know cosine comes first. So we're looking for which of these 4 points has 1 as the first coordinate. And this would be 1, 0. This one's 0, 1. This one's negative 1, 0. And this bottom one is 0, negative 1. So the only place it has that is at 2 pi or 0. But really, those are the same thing, right? 0 and 2 pi. What you would want to look for here is if you were given an interval at the beginning, like if it said to graph this or solve for x from 0 to 2 pi, you would want to look for, is the 0 included? Is the 2 pi included? But since it doesn't say, you can really just include the 2 pi is fine. So now cosine of x equals 1/2. So to find that, I need to think about my 3 ordered pairs. Remember 3, 2, 1, and 1, 2, 3. Everything is over 2. So here cosine, which is the first coordinate, is 1/2. So that's this angle up here, which is my 60-degree angle, or in radians, that would be pi over 3. And I want cosine to be positive. So that's going to be in my first and fourth quadrant. So x can be pi over 3. I know 2 pi would be 6 pi over 3. So 1 less than that would be 5 pi over 3. So now my solutions, your general solutions, would be, we've got pi over 3 plus 2n pi. I think when I do my videos in the afternoon, it must be the internet. I get these lines all over. And then 5 pi over 3 plus 2n pi. And then lastly, I have 2 pi or 0, so we could just call that 2n pi. So no matter how many times you go around, if it's a multiple of 2, you'd be at 0 or 2 pi or 3 pi, 4 pi, or sorry, 2 pi, 4 pi, not 3 pi. 3 pi would be on the other side. So any multiple of 2. Okay, so that would be your final answers there. All right, let's look at another one. So this time, solve 3 sine squared x minus cosine x equals -1 in the interval of 0 to 2 pi. So notice 0 is included, 2 pi is not. So if you got your answer as 0 or 2 pi, you would want to include the 0, but not the 2 pi. All right. So we've got sine squared and cosine x. So we have 2 different trig functions, so we need it to be in one. So here's where we have a sine squared, so we think about our Pythagorean identity. So our Pythagorean identity is sine squared x plus cosine squared x equals 1. Pause your video now and see if you can get the sine squared out and get your equation all in terms of cosine, doing just what we did in number 1, same idea. All right, so hopefully, since we want to sub in for sine squared x, you solved for sine squared by subtracting over your cosine squared. So now everywhere I see a sine squared x, I'm going to replace it with 1 minus cosine squared x. So 3 times 1 minus cosine squared x minus cosine x equals -1. All right, so if you had trouble getting to there, now pause the video and see if you can continue. All right, so now you're distributing. So we've got 3 minus 3 cosine squared x minus cosine x equals -1. Again, you should be able to do this part completely on your own. So I'm going to just jump right to my equation, but you should have the work that you need to show here. So I'm combining like terms, I'm getting it equal to 0, and I'm making my cosine squared positive. So a lot going on here. It's cosine x. A few steps to get to there. All right, so now we have our equation. It's all in terms of cosine, and we have it equal to 0, and our cosine squared is positive. So again, if you haven't done it already, pause the video and see if you can factor this on your own. All right, so again, you would do your 3 cosine squared x, split the middle. I'm going to do it in terms of my cosines, but if it is easier for you and makes more sense, then go right ahead and put in an A everywhere you see your cosine of x. So we've got our p is -12 and c is 1, which means you should have had +4 and -3. Group up your pairs, factor out a cosine of x from the first one, leaving us with 3 cosine x plus 4. Take out a -1 from the second set. So we're negating everything, 3 cosine x plus 4 again. The parentheses are the same, so we regroup. And our leftovers, cosine x minus 1, go in the other set of parentheses. All right, now it's time to solve. So draw your line, set each equal to 0, and solve for your values of x. All right, so you should have gotten here that cosine x equals -4/3. Now the problem there is that, and again, you should have showed that you were first setting this equal to 0. I should see that on your papers. But here, 4/3 is bigger than 1. So -4/3 is less than -1. And you cannot have sine or cosine be bigger than 1 or less than -1. It has to be between 1 and -1 inclusive. You can have it 1 or -1 on the axes, but any bigger than that, it wouldn't work, because that's like saying your adjacent side is bigger than your hypotenuse, which will never work. So no solution there. Here, we set it equal to 0 and add over our 1. Anytime sine, cosine, or sine or cosine is equal to 0, 1, or -1, our point's going to be on the axis. Now with tangent, if that's equal to 1, that's a little bit different, because tangent of 45 degrees is 1. That's going to be on one of the axes if it's 0 or undefined, but not 1. That's for tangent only. Sine or cosine 0, 1, or -1, you're always going to be on one of your axes. So you're looking for which ordered pair has a 1 that comes first, which would be this one over here. So x equals 0 or 2 pi. Now, here's where you again want to go back and look at your interval. So 0 is included, but the 2 pi is the parentheses, so it's not included. So we don't want to include the 2 pi. That's not in our interval. So you would only want to include the 0. So our only answer here is x equals 0. And we don't have to do the +2 and pi, because we were given a specific interval from 0 to 2 pi. And that would be it for that one. All right, and the last one we'll look at here is solve 3 secant squared x minus 2 tan squared x minus 4 equals 0. See if you can pause the video here and try to figure out how you could get this equation all in the same trig function. So either all in secant or all in tangent. All right, so when I look at my Pythagorean identities, and you can scroll up and look at the top, or you could derive it again, but we know that tan squared x plus 1 equals secant squared x. So since I already have this solved for secant squared x, I'm going to just take this and sub it in everywhere I see a secant x. Technically, you could have solved for tan squared x too. That would also work. All right, so now that we got this far, try to pause the video and see if you can take it from here on your own. All right, so hopefully you subbed in your tan squared x plus 1. Now you have everything in terms of tangent. So now you want to simplify, so distribute, and get this equal to 0 with a positive tan squared x at the start. So pause the video there and do that on your own. You should have gotten tan squared x minus 1 equals 0. So you should have distributed your 3, combined your like terms. So you had a 3 tan squared x minus 2 tan squared x gave you 1 tan squared x. And then you'd have a 3 minus 4 gave you the negative 1. All right, so now you have a couple options. You can factor it as a difference of two squares, tan x plus 1, tan x minus 1. Or you could add the 1 over and then take the square root of both sides. So the square root of tan squared x would just be tan x. But whenever you take the square root, you need to remember your plus or minus 1. It's so important because you'll be missing half of your answers if you don't do that. All right, so now here, tangent's 1. So again, sine and cosine, when they're 0, 1, or negative 1, they're always on the axes. But when tangent's 1, that's different. If tangent's 0 or undefined, then it's on one of the axes. But if it's 1, that's going to be your, and this is where you have to memorize these. And remember that tangent is sine over cosine. So if you have sine over cosine, you're taking the second one, dividing it by the first one. The denominators are going to cancel out, so you're really doing 1 divided by rad 3. And that'll give you the tangent. So 1 over rad 3, if I rationalize that, gives me rad 3 over 3. Rad 2 divided by rad 2 would give me 1. Oh, and that's what I want. So now I know my reference angle is going to be pi over 4. Tangent is equal to a positive and a negative 1. So that means we're going to be in all 4 quadrants. So take a moment here, find your 4 angles, and don't forget to add on your plus 2n pi for your general form, and list those all out. So your final answer should be pi over 4 plus 2n pi. That's in quadrant 1. In quadrant, and if you're having trouble deciding what they are, put your 4 pi over 4 here, 8 pi over 4 here. So we've got 1 pi over 4, and then this one would be 3 pi over 4, so 1 less. This one's going to be 1/4 more, so 5 pi over 4. 1 less than 8 is 7 pi over 4. So 3 pi over 4 plus 2n pi. 5 pi over 4 plus 2n pi. And last but not least, 7 pi over 4 plus 2n pi. Okay, so these are really long problems, and there's a lot to think about as you're doing them. So really take your time, focus on what you're trying to do. If you struggled with these, go back and try to redo them completely on your own to make sure you see why these work the way they do. So again, the main goal here is to get your entire equation all in the same trig function, whether that's all sine, all cosine, all secant, all cosecant, all tangent. And we're doing that by using one of those 3 Pythagorean identities. And those 3 Pythagorean identities must be memorized, or at least memorize the first one and then know how to derive the other 2. So you could start off, if you're taking a test or quiz, start off with the first one, derive the other 2 real quick, and then write those at the top of your paper. All right, if you have any questions, please, of course, let me know. And Pi out.